and how they can be useful in your next development process or whatever you're looking at targeting. So let's get started. Yeah, a little background about myself. I graduated from ASU in 2016 with an electrical engineering degree, and since then I've been with Avnet. My background's mostly FPGA reference design creation. This ranges from Zinc development, MPSoC development, a little bit of pure FPGA stuff. Other than that, I have experience in circuit design as well as creating and executing marketing initiatives such as going to tech shows, showcasing stuff, presenting stuff like this. Alrighty, so let's get into what exactly Click modules are. Do any of you guys know what Click modules are? All right, so we got two people. What about PMODs? Okay, yeah, right around the same. So basically, Click module is a standardized board with a standardized header that connects to a female header that is on a development board of some sort. That female header is routed out to SPI, UART, I2C, PWM. It's got a little analog pin on it. So it's basically a plug-and-play system so long as you're using one of the Click modules onto that header. And it just gives you an access to various other end applications, such as actuators, displays, other modules, kind of like a little Lego building block aspect. So if you don't have like a sensor or some other hardware component on your board, you can go on their website. Most of the Click modules that they offer are anywhere from $10 to $20, depending on what you're looking at. And they don't have to worry about PCB soldering or anything along those lines. It's just literally plug and play. So just to make you aware, they have over 700 development boards. I think when I looked at it today, there were 733 little Click development boards. To put that in retrospect, the digital PMOD interface has roughly 100. And a month and a half ago when I was initially making this presentation, they had roughly 680 modules out there. So over the course of a month and a half, they've added close to 50 different modules. And it's an ever-expanding ecosystem. So just to go over some of the quick overview of some of the applications that these modules focus on. They focus on wireless connectivity, so they have modules with Wi-Fi, Bluetooth, GPS, cellular connectivity. You got sensors, so for instance, I got a heart rate click up there. That's a pretty interesting application. They have a interface click, so if you want to adapt to a different interface of some sort, I don't know, you could probably add like wireless antennas on via using various adapter clicks that they have. There's displays and LEDs, so there's LED drivers, there's LCD displays, there's probably some capacitive touch monitors, so you can have that aspect in it. And miscellaneous clicks, so you got your relay click as one of those that doesn't necessarily follow under the same category. Mixed signal, so you got your ADC click, memory clicks, so your EEPROM, eMMC, DDR clicks that help you in your development if you have some constraint in your system. Motor control, DC motor clicks, for example, audio and voice expansion, human-machine interfaces, so you got capacitive touch clicks, clocking, so real-time clocks, and last but not least, they have a section for power management. So you have current monitoring clicks, you have charging clicks, just a variety of different applications in which this can focus on. These can help you with your development. So you're probably wondering what company actually makes these. It's a company called MikroElektronika. It was initially founded in 2001. It's a company that's based out of Serbia. So just to let you know, they don't only offer Click modules. They have roughly 10 product lines. These range from development boards to get you started, Click modules, of course, compilers that they sell to enable your development, accessories for your development, smart LCD screens, and along with various MCU cards to enable your system. Like I said, they have over 700 Click development boards currently available. They estimate they have roughly 120,000 customers currently out there. 60% companies, 20% universities, then another 20% as hobbyists, which is actually quite a bit more than I expected when I was making this slide. And just to make you aware, a lot of their content is featured around Microchip, Nordic, NXP, ST, Maxim. So if you go on there and you have a specific sensor from one of those companies that you're looking for, or various actuators of some sort, there's a high probability that you may find it currently within their offerings. And if it's not, and it seems like a hot item. You may see it in a couple months. So let's talk about the female MikroBUS and how these 16 pins can enable all this development. So on a MikroBUS, the standard is you have an analog pin, a PWM output pin, a reset pin. You got your hardware interrupt line, of course, your SPI communication, your UART, transmit, transceive, standard for UART communication, I2C lines. You got the VCC power line because some clicks operate off of 5 volts, others 3.3 volts. So depending on what click module you're targeting, it'll work for either or. And then, of course, your ground. And on the right-hand side, it's kind of like a little picture of how this MikroBUS is implemented on a Click Mezzanine board that we offer, which I'll get into in a second. Alrighty, so MikroElektronika, along with Avnet's help, went out and designed a 96 boards Click Mezzanine module. So this module is good for any consumer edition clickboard or 96 boards that are currently out there. In particular, most of our development has been around the Ultra 96 board. Yeah, so we offer the mezzanine. It's $16. You have the starter kit. It comes with 3 Click Mezzanines that probably about 50% of our development is behind enabling those thus far. And of course, this is available globally. And there's a link in the top right if you're interested in getting this for whatever 96 board development that you're currently working on. All right, so let's get into what exactly is offered on this Click Mezzanine in conjunction with Ultra 96 or any 96 board consumer edition boards that are out there. First off, I just want to mention that this follows the 96 boards mezzanine design guidelines. So it is good for any consumer edition boards. It interfaces via the low speed count, 40 pin count expansion header that is on all the 96 consumer edition boards. So assuming that any board is built correctly, it should work. Specifically on the Click Mezzanine, you get 2 MikroBUS sites. Each of those are capable of UART, I2C, PWM, along with a analog digital converter is on the board to help with the A to D pin. And that's all through the SPI interface. All right, so software, that's always the fun part. So let's talk about how MikroElektronika enables software development on these modules. So they have a ARM compiler that they sell. It's $299. You get a lifetime license. So any updates, you'll get it for free. Well, not free, but free after you buy the $299 license. So with this, you get roughly 410 working demo code examples to use with your for your development. So all these code examples are targeting different click modules. So depending on what click modules you want for your system, I would recommend that you verify that it will work for this ARM compiler if you're interested in it. And another thing of note is that there's roughly 1,300 supported MCUs. These MCUs range from TI, Microchip, NXP, and ST. So make sure that whenever you're looking at this, that whatever MCU you're targeting is supported. And on top of that, they offer 1,200 working library functions to assist with your development. Alrighty, so now I want to talk about how Avnet what kind of support that we offer behind these click modules when it comes to software. So we went and created a GitHub that hosts a sensor code for the following click modules on the right. So we got a barometer, temp, OLED, light ranger. You got your flame click, you got your relay click. And so basically what we did is initially one of our software developers went and looked at those clicks, found out which sensor is currently on there. They went to the supplier, found some snippet of code to enable their development so they're not starting from scratch, took that code, abstracted it to a more of a click architecture, and doing that we were able to make it more of a cross-platform code. So in theory, you could probably apply this to any development boards that you're using, not just the ones that Avnet offers. And this code is typically broken down into 3 different files. You got your C code with the standard sensor data. You got your C header, and then optionally you may have a C++ header, depending on if that part, the IOs are enabled within that. On top of that, we also have a blog which is in the bottom left-hand side. It goes through pretty much everything that went into abstracting this C code. So it starts with, how I said, go to a supplier, figure out, find some example code and what really went into extracting it to make it cross-platform. Alrighty. So in particular, most of our development has been around Ultra 96. So I wanted to talk to you about how we enable the Click Mezzanine and Click boards on Ultra 96. So Avnet offers 3 introductory courses to Ultra 96 v2, and in particular, those are targeted towards the Click Mezzanine hardware on it as well. So the first course is a hardware course, which you will go through the Xilinx FPGA development flow, in which you'll enable all the Click Mezzanine interfaces. So you'll enable your SPI and I2C, UART, transmission, and as well as configuring the SoC. So after you do that, you'll have all your interfaces available whenever you go to actually do your software development. So going on to the next introductory course, it's a software development course in which you'll take this hardware platform and you'll do some basic bare metal C code applications just to get you familiar with the SDK environment that Xilinx offers. Just to kind of get you started with how everything works. It's a fairly standard Eclipse SDK environment, so you'll probably already be familiar to some degree with it. The next course is a Petalinux introduction course in which you take aspects of both the 2 first courses. You take your hardware platform, you implement into a Linux environment, and use the Petalinux environment to build your image and get started with an actual application. In particular, in this application, the application that you run on there, in the Petalinux course that is, you run a IBM Bluemix IoT application in which you take sensor data off of one of the Click modules that is for the course and send that up to the cloud. And then you can visually see it in a graphical interface. Another way of enabling it that we offer is we have another blog that is all about demos and how to get them running on your platform. In particular, we target a non-96 board interface, but the same principles can be taken and applied to your system. It's basically where to go for your application code, how to compile it, then running it on your system. And it goes through all the supported examples that are currently out there and available from Avnet's GitHub, that is. Alrighty, and now I have a little demonstration, but let me see if it's working. So my network's not working for the Ultra 96 currently, so I'll just talk through it real quick. Alrighty. So like I was saying earlier, in the Petalinux introductory course, you go through, you add your hardware platform, you take example C code that's provided and implement it into your system, as well as configuring the kernel and whatnot to support all the interfaces. So this is that application that I'm talking about, in which you're fetching temperature data, and it's being displayed over IBM Bluemix using the MQTT protocol to send data up to the cloud. So this is just one example of how Petalinux can help with your networking capabilities. And I wish it was working. It's a pretty neat demo to actually look on your phone and watch it work. Alrighty, so this is kind of more of a recap slide. So we're talking about the MikroBUS and what does it really solve. First off, time wasting. That's one of the biggest components or one of the biggest things that it solves. So you don't necessarily know what you want your application to be hardware-wise, and you want to mix and match and play. This pretty much eliminates soldering, no wires, no time wasting. Like I said, there's over 700 expansion modules currently available, which is an incredible amount of, applications and whatnot. And of course, there's the MikroC Pro for ARM that's currently available. So if you have an MCU of some sort that is, compatible with this, I would highly recommend you take a look at that. And in addition, there are low-cost sensors. And I mean, there's some expensive ones depending on what you're looking at, like the high current ones. But for the most part, they're $10 to $20 depending on what you're looking at. Alrighty, and just so these are just some next steps on where you can go for more information. On the top link, it takes you to a link of a brochure where it shows all the various sensor modules and what they can do and whatnot, as kind of just a show and tell kind of thing. The second link takes you to the ABNet GitHub, where it shows you all the sensor code that we currently are supporting, or we're currently working on. And then the last one is design with Click modules. In particular, I want to focus on the Click Mezzanine that we offer to enable you on your 96 board development. Does anyone have any questions? Where's the...
So you mentioned that the modules are quite inexpensive,
Yep.
but then the software is $299. So does everybody have to get the $299 software?
It's just the compiler if you want to use what MikroElektronika currently offers. But I mean, if you want to do your own software development or leverage the ABNet's software development, you could work pretty much in whatever compiler that you typically use. So it's not required. It's just if you want to have access to the 410 example codes that they offer and the 1,400 libraries or so that they offer.
Okay.
Yeah.
Thanks.
Yep. What's that?
So on the 96 board, you'll have the full Linux running, is it?
Yep.
So you can just write modules and do...
Yeah, correct. Yeah, it's basically just an interface for talking to that sensor.
Right.
You just standard I2C, SPI, nothing too crazy. By that guy. Yep. Yeah, so if you're interested in Panalinux and how to work with that in regards to Ultra 96, that's an excellent course.
The Petalinux, is it a different distribution itself, or is it software running on Linux?
Yeah.
It's a different distribution. Okay, I see.
Yep. And I got the hardware up here if you guys are interested in actually taking a look at it. I'm kind of frustrated the demo didn't work, but yeah, here we are. All right, any more questions?
Do people use it mostly for demos, or do they actually commercialize with these boards?
I view it as more of a prototyping aspect. I like it for demos since I do kind of a fair amount of that, but yeah, it's more of a prototyping in which you would buy that little Click module, put it on a board, and then once you're finished with your application and you're ready to go to market, you do a chip down design with that sensor on it, and
right. Okay.
from that standpoint,
Okay.
yeah, just to enable you to get started with your software development right away.
Like if I have some idea and I want to actually prototype and showcase it.
That's correct. Yeah, that's an excellent opportunity for it.
Yeah, okay.
Yep, with the 700 plus modules that are available. Okay. Well, thank you.